Okay, this is Math 2. We're going to do 95 to 101. And since I did 95 in class this morning, I'm not going to go over 95. It was a very long problem. So we're going to start with 96. I'm going to skip 97, I think, until the end, because it's actually a really long problem. So if I run into it, I might just do 97 on its own video. And then we're going to go through. The rest of this should be pretty easy to do. Yeah. Okay, so 96. First one says, algebraically solve the system of equations for x and y, then graph the system to confirm your solutions. So a system of equations with respect to a linear function and a quadratic function, in order to figure out what the value of x is, you actually have to set both equations equal to each other. So we have x squared plus 2.6x plus 0.45 is equal to 2x plus 1. And I'm going to subtract 2 to both sides, subtract 2x from both sides, sorry, and negative 1 from both sides. So minus 2x minus 2x minus 1 minus 1. So we have x squared plus 0.6x minus 0.55 equals 0. All right, now here's your quadratic. My advice is to do the quadratic formula. So we have negative b is 0.6 plus or minus the square root of 0.6 squared minus 4 times 1 times negative 0.55 all over 2 times 1. And if you're doing this correctly, and I really hope you're going to show your steps, you should get, actually wait, where's my graphing calculator? You should get that x is equal to a number and x is equal to another number. I forgot what they were. I think it was like 1.1 or 1 and negative something. So whatever value you get for x, whatever value you get for x, you need to plug back in. My advice is don't go for the ugly quadratic. Go for the really nice linear function. Whatever x value you have, it needs to be plugged in. Whatever x value you have, it needs to be plugged in. And you should get a y value and a y value back out. And your final answers should be in coordinate format, meaning x comma y for one of the points, and then x comma y for the other point. So x and x, plug it in separately, obviously, not at the same time. That wouldn't make any sense. And then get two different values of y, and whatever x you plugged here goes with the first value, and so on and so forth. That was 96. 98 should be pretty easy to do. So the question is, off this function here, if you have this graph and you have plus 3, what does that do to it? Well, plus 3 is not inside the parentheses. It's going to be on the outside. So that means everything moved up 3 units. So technically this value, which I'm going to do in blue right now, everything moved up 3. So 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3. Okay, so the graph now looks like this. Or I should say the function now looks like that. So this is the first one. This is f of x plus 3. It moved up 3. Okay, I'm going to do c next because c is going to be like actually easier to do. So c, which is f of x plus 3, it's inside the parentheses, so you're actually doing the opposite. So we're going to go to the left 3. So we're going to take this function, we're going to move it to the left 3. So we have 1, 2, 3, 1, 2, 3, and everything moved to the left. Wow, that was horrible. What just happened? Something went wrong. 1, 2, 3. 1, 2. Okay, that's correct. What did I do wrong here? 1, 2, 3. Oh, I didn't move this correctly. Okay, there we go. That makes more sense now. Okay. So this pink one is the original function moved to the left 3. Okay, and then this one. When we had parabolas, multiplying something by a whole number or something greater than 1 actually made it vertically stretch. So that means all the y values are vertically stretched, which means all the y values here are going to be multiplied by 3 so that you can actually vertically stretch it. So instead of having, let's say, the y value at 2, which is, this is 2, it's going to be multiplied by 3, so now the y value is going to be at 6. So instead of 4, 5, 6, it's going to be up here now. The x still stays the same. It's just stretched. This y value is also going to be at 6. Negative 2 times 3 is going to be at negative 6. And negative 2 times 3 is also going to be at negative 6. So that means everything in between got multiplied. Here it is. All the values stretched. So this is the function of this one in the middle. It was vertically stretched by a factor of 3. Yeah, okay, we're good. All right, 99. For each geometric representation or relationship below, write and solve an equation, show all your work. So in this one, we have interior angles inside a polygon. And 1, 2, 3, 4, 5. So we have 5 sides minus 2 times 180. That is the interior angle sum, right? And interior angles of any polygon is going to be 5. The number of sides minus 2 times 180. So 3 times 180, in this case, is going to be 540. So all of these angles need to be added up and equaled to 540. Okay, and then you should get a value for x, and you should be good to go. So this was your clue, 5 minus 2. Actually, that was probably what the hint was. Okay, B, you have 4x plus 20, you have a 5x minus 2. 4x plus 20 is actually this angle right here. Okay, and if you take tracing paper, and, well, you don't really need tracing paper, you have parallel lines and a transversal, your corresponding angle to 4x plus 20 is going to be this one. So this is also 4x plus 20. And since 4x plus 20 and 5x minus 2 are on a line, adjacent next to each other on a line, and a line is 180, then technically 4x plus 20 plus 5x minus 2 added together should be equal to 180. This is your linear pair. So 4x plus 20 plus 5x minus 2 is going to be equal to 180. And then solve for x. Okay, that was 99. 100. Ooh, I'm on a roll. It's only been 8 minutes. The area of the sector of a circle is given by the equation. Area of the sector is equal to theta, or the angle, your central angle, over 360. Times pi r squared, where r is the radius of the circle and theta is the measure in degrees of the arc of the sector. So solve the equation for theta, solve the equation for r. Okay, so it's not that difficult, but it does require some manipulation. So A is going to be equal to theta over 360 times pi r squared. All right, now, normally, to cancel out a denominator of a fraction, you just multiply on both sides by whatever's in the denominator. So I'm going to multiply both sides by 360. Okay, so that gives you a 1, right? For 360 over 360 is a giant 1. So 360a is going to be equal to theta times pi r squared. All right, well, I want theta by itself, and this whole thing is being multiplied by theta. So doing the opposite of multiplication, in this case, which is division, I'm going to divide both sides by pi r squared. All right, so that means I have 360 times the area over pi r squared should give me the angle of that's solving for theta. Okay, so you're pretty much going to almost do the same thing for r. I'm going to let you try r on your own. Okay, you're just manipulating and trying to get r by itself. Eventually you will have to square root though. Okay, 101. Assume that two figures on a flat surface A and B are similar. Okay, so I'm going to draw two figures, and I love to draw the potato chip. I love the potato chip. Here's a flat Here's a potato chip, figure A. And here's another bigger potato chip. We're going to call it figure B. It's a funny potato chip. They are similar. I don't care what the picture looks like. They are exactly the same, except B is the blown up version of A, or you can say A is the reduced version of B. So if the linear scale factor is 2 to 5, then what is the ratio of the areas of A and B? So let's say that you find this from here to here is, I don't know, let's use like a 1, right? Well, this from here to here is 2 over 2/5 of this one, the linear part of this potato chip. So that means I would take 1 and then I would multiply it by 2/5 and get, hey, 2/5. So that means this is 2/5 the linear scale factor of that one. So this is 2/5. So this is the linear factor. This has to mostly do with the perimeter. But the ratio of the areas is actually squared off of the linear scale factor. So that means for area, I'm going to multiply by 4/25. So the ratio of the areas of A and B is going to be 4/25. Areas squared, the linear scale factor is squared to get the ratio of the areas. If the ratio of the perimeters of A and B is 4 to 1, what is the ratio of the areas? Well, okay. So let's do the perimeter. So if the linear scale factor, let's do another one. We're going to have potato chip, potato chip. Okay, here's A and B. I guess this is for problem A, and this is going to be from problem B. If the ratio of the perimeters is 14 to 1, okay, well this is going to be 14. This is going to be a 1. So what did you multiply 14 by to get a 1? Okay, well, you multiplied, if nobody knows, you multiplied by 1 over 14 to get a 1, right? So what is the ratio of the areas? Alright, well, you multiplied by 1 over, what's 14 squared? I don't know what 14 squared is. 14 times 14. 196. 1 over 96. 1 over 196. Alright, so if it's 14 to 1, did I do that right? Or is it supposed to be backwards? No, I think I'm okay. 14 to 1 times 2/5. 14 to 1. I think I did that wrong. Oh well. I'll fix it later. Okay. If the area of 80 of A is, I guess this is for C. I'm pretty sure I did part B wrong. I think it has to do, okay, I'll figure it out in a second. If the area of A is 81 times that of B, what is the ratio of the perimeters? Oh, this is easy. Okay, here's another potato chip A, potato chip B. Okay, we don't know what the ratio of the scale is, but we do know that multiplying by 81 is how you do the area, so that means the linear scale factor would have been multiplied by 9, because a square root of 81 is going to give you your 9. Okay, alright, I think that's it. So your area is going to be multiplied by 81, but your linear scale factor is going to be multiplied by, oh, I know what I did wrong. I did this backwards. No, this still kind of works. The ratio of the areas is going to be 196 to 1. So if it's 14 to 1 on the linear scale factor, then the area ratio is going to be 196 to 1, because 14 squared is 196, 1 squared is still 1. Okay. All right, so I'm going to stop here. So if you still need 97, I'm going to do that in the next video.